IOE 413 Radiation Therapy Planning Study Guide. This question wants you to write down the reduced primal form of the radiation therapy planning problem. Recall that X sub I is the dose to tumor. Underline that because that's important. Voxel I. And Y sub I is the dose to the normal tissue voxel I. Now there are a couple things that we know have to be true. The first one is that in the formulation, X is bounded below by a vector X superscript L and bounded above by X superscript U. So X superscript L is a vector of lower bounds on X, and X superscript U is a vector of upper bounds on X. So X is bounded between these two. Basic physics also says that A sub t relates the vector W to the vector X. So X is this dose vector for tumor voxels. W is a vector of beam weights, and A sub t transforms the beam weights into the doses. We also have Y is equal to A sub n times W. And A sub n transforms the beam weight vector W into doses in the normal tissue, Y. And finally, our cost coefficient in our objective function is going to be A n transpose E. So the linear program that we want to write down is minimize Z is equal to C transpose W such that X is equal to A sub t times W. There's a lower bound of X superscript L, and there's an upper bound of X superscript U on X, so X is bounded below by XL and above by XU. Then we have A sub n W is less than or equal to Y, and W is greater than or equal to 0. And that's our linear program for the reduced primal model.